Okay, so this is going to be a relatively short lesson on Hero's formula. We're not going to get really heavy into it. You have a couple homework problems from the 12.5, the ratio of areas. You'll have 3 from this. There's 2 opening problems here. I think they'd be great for you to do, to give them a try. They're kind of neat. So if you want to stop this and give these a shot, and then we'll get into the lesson a little bit. When you come back, I will go through these openers. So, but go ahead and give it a go. So shaded area is 65 pi. Find the length of a chord of the outer circle tangent to the inner circle. So, I always love to draw in a radius. I'm going to extend that. I hope you realize that would be perpendicular, right? And let's see, what do we have here? We have the shaded area is 65 pi. Okay. And we're going to call this x, and we're going to call this y. Okay. And to find to solve this, we can set up a little equation. Okay. The area of the whole thing, of course, that would be pi r squared. Well, r would be x plus 5 squared times pi minus the inner circle, which is pi r squared. And that would have to be 65 pi because that's what was given to us. Now, sure enough, all these pi's would cancel out, so we don't have to worry about that. We distribute that squared, so we get x squared plus 10x plus 25 minus x squared equals 65. So that's kind of cool too, because these x squareds cancel out. And what do we got here? We got 10x equals 40, so x is 4. Okay. Now, if x is 4, that means the radius of this entire big circle is 9. Okay, so now we can find y, of course. 81 using Pythagorean theorem minus 16 equals y squared. So you get square root of 65 equals y. And they're asking for the length of that chord, so it's obviously 2 root 65. Okay. Rouleau triangles, a curve of constant width constructed by drawing. This is kind of neat. It is an equilateral triangle, so we have 60 in each corner. And how I approach this one, I'm not really sure if it's the best thing. So this curve is part of a circle centered here. This one part of a circle centered here. This one part of the circle centered there. So what I thought I would do is I would find each segment. So I have 3 of these segments. Okay. We're asked to find the area of this whole thing, but let's find the segments first. Segment, remember, is the sector minus the triangle. Okay? So, the sector, this is 60. So we're talking about 1/6 of pi r squared. So that would be 144 pi. Okay, minus the triangle, which is equilateral, side squared root 3 over 4. This comes out to 24 pi. This comes out to 36 root 3. Okay, now you have 3 of those, right? So you have 3 of those. I just found the area of one of these. So we multiply this by 3 now. Okay, but then if I multiply by 3, that gives me these 3 outer segments. Remember, I still have to add in this equilateral triangle, which we had earlier found to be 36 root 3. So this comes out to 72 pi. And if you distribute that and add in the 36 root 3, you get minus 72 root 3. All right. So Hero of Alexandria developed this formula a long time ago. And the proof of this is incredibly long, and you would not be happy if we were deriving that right now. So I'm just going to give you the formula. So the Hero's formula is the square root of this long thing. This is S, and then it's going to be S minus A, S minus B, times S minus C. S, you see here, is the semi-perimeter. So you add up the three sides, divide by 2, and then you're multiplying, semi-perimeter times S minus A, S minus B, S minus C. We'll do a problem with that in a moment. Brahmagupta's formula is very similar. It's used to find, by the way, Hero's formula is used to find the area of any triangle at all. Okay, works. Brahmagupta's formula is used to find the area of any inscribed quadrilateral in a circle. Okay, only can be applied to quadrilaterals, can be inscribed in circles. It looks very similar to Hero's formula. The only difference is you don't have that S in the front. So this is going to be S minus A, S minus B, times S minus C, times S minus D, because you have a quadrilateral. S, again, is the semi-perimeter, adding up all the sides of the quadrilateral and dividing by 2. Okay? Again, I just wanted to give you some basic exposure to this. We're just going to do a couple problems here in the back, and then some of these problems that are on the back will be assigned for homework. Okay? It says, you use Hero's formula to find the area of an equilateral triangle 8 units long. It's much easier to do this problem with side squared root 3 over 4, believe me. But if you want to practice your Hero's formula, you should get 16 root 3. So let's go ahead and do number 2 together, though. If I'm going to do Brahmagupta's formula, I first have to find S. So I add these all up. 12, 16, plus 10 is 26. So my semi-perimeter is 13. The area, remember, Brahmagupta's does not have that extra S in the front. So I do 13 minus 5, 13 minus 7, 13 minus 4, 13 minus 10. And you have kind of some big number here. But this does come out to be a perfect square, actually. You would get 36, okay? Just so you're aware. This one here, again, you can add these up easily. Obviously, that's 20, 26. So we have semi-perimeter again of 13. And this would be 13 minus 1. So 12 times 8 times 4 times 2. And again, the numbers are a little bit big. But, what you can do is you can kind of simplify this fairly easily. 4 is perfect square. So that comes out as a 2. 8 times 2 is 16. That's a perfect square. So that comes out as 4. Turns that 2 into 8. So you have 8 root 12. And then you simplify the 12. And that ends up being 16 root 3. So that's kind of a handy way of doing that simplification with a very big number. All right. Find the area of an inscribed pentagon to the nearest tenth. So when you have a pentagon, that doesn't, that's not a quadrilateral. So what we can do is we can draw this in here, and we can make a triangle and a quadrilateral, okay? And let's see here. It says in that order, so 5, 5, 5, 6, 8, okay. Let's see here. What do we know about... Okay, there's something I'm missing here, but let's see here. I think, well, you were supposed to have some, yeah. I see so this stuff should have been written in here to begin with, and you were given that this is a right angle. Okay, so my bad on that. I knew something was freaky, that's why I had that big pause there. So, sorry about that. So 5, 5, 5, 6, 8, this is a right angle. So if that's 6 and that's 8, this is 10. So now we can easily do the area of the triangle. That's just 1/2 of 8 times 6, which of course is 24. Now the quadrilateral, we can use Brahmagupta, and we got a semi-perimeter of 12.5. Okay. If you add all those up and divide by 2. So the quadrilateral area is going to be, 7.5, 12.5 minus 5, which would be 7.5. And then you're going to have that, you're going to have to use your calculator here, obviously with the decimals. And then you have 2.5 on the end. And this should come out to 32.48. Add the 24, 56.48. Okay. All right. I didn't do one with heroes, so I'm going to quickly do number 4 with heroes. Obviously, it's a right triangle. You can find this area immediately by doing 1/2 base times height. But if we were to do heroes, the semi-perimeter, if I add those together, I get 17 and 13, I get 30, divide by 2. And remember with heroes, you have the S in the front. 15 minus 5, 15 minus 12, 15 minus 13. Okay. This one might be a little bit harder to simplify. There's no like obvious perfect squares that you can get right away. This ends up being just 30 though, because it comes out to, 900. Okay. Your homework is going to be problem, and it says here to, the instructions said to do the following in 2 different ways. You don't have to do it in 2 different ways, okay? Just one way is fine. And I would like you to think of heroes or Brahmaguptas where applicable. I would like you to do problem 6, problem 8, and problem 9, okay? The answer here is 12 root 5 for number 6. The answer for number 8 is 336 minus 64 pi. You might want to just do these on a separate sheet of paper so you have a little bit more room. And the answer to number 9 is 153 over 2. Number 9 ends up being much easier than you realize, so think about it for a second before you start just cranking away. All right, so those are the 3 answers for those. Guys, be good.